Hello students, I am Nilanjana Senyal. Welcome you all to my channel MS Online Math Classes. Our today's topic is 4 important properties of logarithms. In our previous 2 sessions, we have learnt about some restrictions on logarithms, and in our today's session, we will be learning about some important properties of logarithms. So without any further delay, let us start with our today's session. The first property, log of a to the base a is equal to 1. Whenever you have the argument and the base to be the same number, the value of that log term will be equal to 1. It may be log 5 to the base 5, that is equal to 1. It may be log half to the base half, that is also equal to 1. Whenever the argument and the base you have both of them to be the same number, the log term, the value of that log term is equal to 1. Why is it so? If you convert this to the corresponding exponential equation, this subscript a is the base, this a is the argument which becomes the answer for the exponential equation, and this one is the product or result which will become the power of the exponential equation. So we have a to the power of 1 equal to a, and it is a valid equation because we know any number raised to the power of 1 is that number itself. Therefore, log of a is equal to log of a to the base a is equal to 1. Okay, and you have the restrictions. You know that the base cannot be equal to 0, it cannot be equal to 1, it cannot be a negative number, and the argument cannot be a negative number, it cannot be equal to 0. You have those restrictions, and you can have any other value, but you cannot take the values which are in the restriction part. Okay. So for example, log 2 to the base 2 is equal to 1. Another example, log 10 to the base 10 equal to 1. Over here, I have written this 10 in the subscript as the base explicitly, but we usually do not write the base 10 explicitly. Whenever you see that you have log and then the argument, the base part is missing, you have to assume the base to be equal to 10. Okay? And it is not just valid for small numbers. You may have large numbers as well. You may have log of 5000 to the base 5000. This will also be equal to 1. Okay. So coming to the next rule or next property. Log of 1 to the base e equal to 0. E is any number, any positive number, not equal to 1 obviously, but any other positive number. And log of 1 to any base to any positive number except 1 is equal to 0. Why? Again we convert to its corresponding exponential equation. And what do we get? We get this e is the base, 1 is the argument which becomes the answer, and this 0 is the product or result which will become the power in the exponential equation. So it is e raised to the power of 0 equal to 1. And we know any number raised to the power of 0 is indeed equal to 1. Therefore, log of 1 to the base e is equal to 0. Whatever may be the base. The base is a positive number, of course, not equal to 1. And it will always be equal to 0. Okay. For example, log of 1 to the base 3 is equal to 0. You can take log of 1 to the base 200 also. That will also be equal to 0. Okay. So, I have taken another example. Log of 1 to the base 10 equal to 0. And you have log of 1. This is a fraction. 0.5, it is a fraction. Log of 1 to the base half, this is also equal to 0. Okay. Coming to the third property. Log of e raised to the power of x to the base e is equal to x. Why is it so? e, this subscript is the base, e to the power of x, this is the argument, and this x is the product or result, which will become the power of the exponential equation. As we have done in the previous two cases, we will be converting this to its corresponding exponential form. The base will remain the base, this argument e to the power of x will become the answer, and this x, this is the product or result of the logarithmic equation, this will become the power of the exponential equation. So it will be e raised to the power of this x equal to e to the power of x. You see, e raised to the power of x equal to this a to the power of x. And of course, it is a valid equation. So therefore, log of e to the power of x to the base e equal to x. This is not, these two are very easy to remember. But this one and the next one that we will be seeing, these two are not so very easy ones. But of course, when we will be knowing some other properties of logarithms, we will be seeing we can bring this x down, and then you will be having log a to the base a, which will be equal to 1. And this will be a very, very easy formula at that time. Okay. Now it may look some a weird type of an equation or a formula, but it will no longer remain a weird type of a formula once you know the other properties of logarithm. Okay. So, for example, log of 4 raised to the power of 20 to the base 4 is equal to 20. Only the power will be the answer. Okay. So, coming to the fourth property. This is just the opposite. This is the logarithmic equation. Now, this one is the exponential equation. E raised to the power of log of x to the base e is equal to x. This is an exponential equation where the power is containing a log term. E raised to the power of log of x to the base e. See, this e and this e, these should be the same, equal to x. So why are we having this type of an equation? Since this is an exponential equation, this time we will be converting this to a logarithmic equation. Its corresponding logarithmic equation. Okay. And this is the base, this e is the base. The power is log of x to the base e. Okay. And this is the answer. Answer is x. B, P, A. B stands for base, P stands for power, A stands for answer in the exponential equation. This will be getting converted to BAP for the logarithmic equation. B will be the base, E, the answer becomes the argument, and P, the power, becomes the product or result. So if we write this exponential form, if we rewrite this exponential equation as a logarithmic equation, what happens? It is log, obviously because it is a logarithmic equation, it should start with this word log. Base, the subscript will be e, base remains the base. The answer becomes the argument, so it is log of x to the base e equal to the power becomes the product or result. The power is log of x to the base e. So it is equal to log of x to the base e. You see the left hand side and the right hand side, they are the same. So this is a valid equation. Hence, we have, even though it is a very, very cumbersome equation, it is not at all a good looking one, definitely. But it is a valid and one of the most important properties of logarithms. E raised to the power of log x to the base e is equal to x. Okay. So this is one of the examples. 7 raised to the power of log of 10 to the base 7 is equal to 10. Okay. So students, I have given you 4 important properties of logarithms and you will be needing them so often in solving questions on logarithms. Okay. So, and these two, even this one, these first 3 are very easy to remember. Not the 4th one, but you have to remember this as well. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.